Oh, thank you, Caitlin. Wonderful job. Okay, here we go. So guys, I don't know if any of you have been going on to watch the videos. Say you go home and you're struggling with something and then you rewatch the video. You'll find that like the videos are long. It'd be different if we were remote learning right now because it would just be me making the video, no questions and that sort of thing. So the videos would probably be half the amount of time. So like make sure that like feel free to like skip through, right? Like the video might be an hour long, but there's a lot of like chit chat throughout and that sort of thing. So please don't like let that length of the video discourage you. Like you can skip along to like the part that you need help with, right? Because those are there for you guys for extra help. Okay, I'll try to keep pulling my mask up, but the mic does pull it down a little bit. Okay, so applications of trig. So now we are going to take our SOHCAHTOA, our 3 primary trig ratios, and we're going to use them to be able to solve word problems. So this is like the real world application. So you will need to draw labeled diagrams. So this, like I said, I find is the most difficult part. So draw a labeled diagram. Include a let statement for word problems. So every single time we've done word problems, we always have let statements. Let x be, in this case, we're going to have like angle of depression, angle of inclination. Show all of your work, including which trig ratio you're using, and answer statement if it's a word problem. Okay, so draw a label diagram, include a let statement, show all of your work, answer statement. You're there for. Okay, nothing new there. This first question that we do isn't necessarily a word problem. All the rest are. This first question that we're going to do involves being able to figure out multiple unknowns of a triangle. So sometimes you're going to have questions where you have one side that you don't know, maybe 2 angles that you don't know. So this would be a question where there's multiple unknowns to figure out. Okay? So it says here, solve triangle ABC. Given AC, so that's like a line segment, pretty much AC, is 4 centimeters. BC is 1.5 centimeters. And angle B, can you guys add that in? Should say angle B is 90 degrees. That wasn't the best angle. So I want you guys to write here, solve for all sides and all angles. So number 1, we're going to draw this guy. So we have a line segment AC, so A connects to C, B connects to C, and then we have an angle B of 90 degrees. So I'm just going to go like this. Ugh. Yours will be nicer than mine because you can be using a ruler. So if this is my 90 degrees, what am I going to label this guy, this vertice? Wonderful. Now, it doesn't matter where you label A and C. You could have labeled C up here, A over here. It doesn't matter. You also could have drawn it differently. You could have drawn it like this. Okay, you could have drawn it like this. Right? They're all the same. Okay, we're going to use this one because this is the one that I initially drew big, but all of those are correct. Okay, are we okay with that so far? So it says angle B is 90 degrees, so we got that, and then it says AC is 4 centimeters. So this is our AC, so 4.0 centimeters. What is this again? What do we call this side of the triangle? The hypotenuse, okay? So this should be the longest side of the triangle, lengthwise. Okay, and then BC is 1.5 centimeters. So it says, solve for all sides and all angles. So we don't have this angle. We don't have angle A, sorry, we don't have angle C, and we don't have side length AB. So there's 3 things that we need to figure out for this triangle. Okay? So let's start with figuring out angle A. So right here, we're going to put theta, because we don't know that, right? Theta represents the angle. Remember that from yesterday? So I'm going to put here angle A. So you guys tell me, we want to figure out angle A. So how am I going to do that? Think about what we have and what we can sub in order to get angle A. What do you think? So what is this side to angle A? Opposite. And then what other side do we have? Hypotenuse. So if we say SOHCAHTOA, what are we going to use to get angle A? You told me we have opposite and hypotenuse. Sine. Okay? Are we all good with that? So you guys are going to write sine. Now listen, you can put theta here or you can put A. It's the same thing. Okay, because we have multiple angles here and we're going to have to do solving for angle C as well, I'm just going to put sine A. But don't let that confuse you because yesterday you were seeing theta here, but it means the same thing. Okay? So sine A equals up over height. Sine A equals, what am I going to sub in for op? And height. Good. Now, what do I do next? So remember, it's A that I want. It's the angle that I want. So what do we always have to remember to do? What operation? The inverse operation. So I'm going to change this around, and it's going to look like this. Sine to the -1. Now, you could have put this into a decimal first if you wanted to. It doesn't matter. If you like to do that first, by all means, you don't have to. So I'm just going to put 1.5 over 4.0. And if you guys were to punch that into your calculator, you would have gotten 22.0 degrees. Okay, so you could also have sine to the -1 and then in brackets the decimal here. Okay, if you did that on a test, that's fine. Okay, so I'm going to fill that in here. I'm going to put 22 degrees. Okay, so I'm just going to say like this is our first step. You guys go back to the note. Now, for our second step, let's find angle C. Okay, so now we want to figure this guy out. So you guys tell me. We want to figure this out. So think about what do we have? Think back to SOHCAHTOA. Think about if you were going to label. So this side would be what to angle C? Opposite. Do we have this? No. So we're not going to use that in our equation. Wouldn't make sense to. But we do have adjacent and hypotenuse. So what trig ratio are we going to use? Cos. Good job. So you guys can write angle C. Cos, and again, you could have put theta here, but I'm going to put C because we have multiple unknowns that we're trying to figure out. And you guys told me it's adjacent over height. Adjacent is 1 point, good. Height is 4.0. If you want to get theta or the angle C, oh, sorry. Can someone put 1.5 divided by 4.0 into their calculator for me, please? 0.375. So this one, I'm just going to put it this way so that if you go back to your notes, you know that both ways are just fine. Okay? And then you would have gotten 68.0 degrees. Now, I want to remind you of something, and I don't know, I can't remember if you guys do this in grade 8, grade 9, or if you even do it in elementary school, but have you guys done, like, what is the sum of the interior angles of a triangle? Yes, okay, I thought that you have done that. So, we did do it this way, which was a little bit of a longer way, but you also could have done it a different way. And can we all see down here? Is it okay if I put it down here? Okay, so, or, if you wanted to get angle C, you could have also done the sum of the triangle of the interior angles is 180, minus, we already got 22 over here for angle A, minus 90, because we already have that, and you would have gotten 68. So I know you're probably thinking, why didn't we just do that? But I just want to show you both ways. Okay? It's almost like a shortcut that way. Okay, so we have this, what do we have left? We have the left side left over, so we need to get AB. We have to get the length of it now. So we have our angles, we have our lengths of our other two sides, but we need to get the length of AB. So, guys, there are multiple different ways to do this. On my paper, I think I wrote 4 ways to get this. So there are a whole bunch of different options. I'm going to put down the first way. So 3 here is going to be to get a B. So it all depends on like where you start in the triangle. So let's just like talk about it for a second before we actually go and do this. So if I was looking at angle A and I want this here, there's different ways that you can do it. So I could say, well, opposite of angle A is 1.5. So I have O, opposite, but I need adjacent. So O and A would be, what trig ratio would I use? Tan, right? That would be one way to do it. If I was looking at angle C, and I said, okay, I need this side, so that would be opposite, and I have adjacent, that would be using 68 as the angle in the equation, and then O and A. So do you see how I'm saying that there's a whole bunch of different ways to do it? You also could have said, I have angle C, I need O, but I have H. So if we have O and if we need O and we have H, that's O and H, which would have been sine. So do you guys see what I'm saying? That there's like a whole bunch of different ways that you could do this? Yes? Okay. So the way I did it was using cosine. So let me get this down and I'll show you. So the way I chose to do it was I'm looking at angle A, so I have 22 as theta. I also need to the side here is what again? To the side of angle A? Adjacent, and I have hypotenuse. So that's just the way I chose to do it. So looking at angle A, it's going to be cosine because I need A and I have H. So that's this guy here. Okay? Is everyone good with that? But like I said, there's so many different ways to do it. Okay? So, cos 22. So, we have adjacent and hypotenuse. Do we have adjacent? No. So, you can sub in X for that or you can keep it as adjacent. It doesn't matter. You would get full marks either way. Over height, which is? Good. Now remind me, how do I get rid of this fraction? What do I have to multiply both sides by? Good. Okay. Bop, bop, bop. So can someone do this in their calculator for me? 4.0 times cos 22, just so that we can make sure that we all get the right answer. What do we get? 3.7. 3.7 what? Centimeters. Right? If those guys are in centimeters, then this should be in centimeters as well. Okay, so, sorry, I'll put adjacent. Or this could have been x. You could have subbed x in there. Okay? We could have went like this. Like that. It doesn't matter. No. It's not necessarily to scale all the time. But good point. Okay. Now there's one last thing that I wanted to show you. So I hope you have a little bit of space. We did angle A. We then did angle C. And then we just wanted AB. So yes, I am teaching you using trig ratios. But if you have a right angle triangle, and you have this side, which is what again? What do we call this side? The hypotenuse. And we also have another side. What's another way that you guys have learned in the past to just be able to get this side here? Oh, come on, I know you know it. This is a right angle triangle. This is the hypotenuse. We have another side. How do we just get the other side? Pythagorean's theorem. Okay, so you also could have done that here to get the right answer. So don't hate me, but let's just do it so that you guys have it in your note to know that that's something that you could have done. This is probably the longest slide. 8, I think. Okay, so I'm just going to do it because you guys have had a lot of practice with. So, I have this, which is, do you guys remember, A, B, or C? Is hype, what is hype always in Pythagorean's theorem? Do you guys remember? It is C. So this here is our 4 squared, because 4.0 is that side, the hype. So let me just put this here. Hype is always C. The other two sides don't matter. I could solve for A or I could solve for B. That was squared. Okay, so this would have been also another way to do it. I subbed in my length of the hypotenuse, which is C, 4 squared. I subbed in another side. I happened to choose A. 4 squared, bring this guy over, subtract, because he's positive on the right, 1.5 squared. Then you would take the square root to get rid of the squared here. 3.7 centimeters equals B. Do you remember doing this? Pythagorean's theorem? Okay. In order to get B on its own, you have to take the square root to get rid of that squared. So if you take the square root of the right side, you have to take the square root of the left side. Okay, and what do we get? The same answer. Okie dokie? Questions? Okay, so you're going to get questions like this. You're going to have an in-class assignment tomorrow. So like, even on the test too, right? You can be given a triangle and have multiple unknowns to solve for. But just take it one step at a time. Okay, this is nothing new from yesterday. You did this, this, and this yesterday. It just is a whole bunch in one question. Okay? Now, I want to make sure that we're understanding that there's multiple ways for this. So tell me one more time. If I wanted to figure out AB using a trig ratio, we happen to use cos here. But if I wanted to look at this angle, give me one. Someone give me one that you could have done or could have used that's different than cos. So if I'm saying I'm going to use 68 degrees as my angle, and I'm trying to figure out this side. So the opposite Okay, so we could have done tan of 68 because we need the opposite, but we have the adjacent. So O and A. What's another one if you still used angle 68? I need opposite, but I have hypotenuse. So you could have done sine of 68, O over H. And it's all going to give you 3.7, every single answer. Okay? All right, moving on here. First word problem. The distance between two floors in a new home is 2.5 meters. The horizontal length of the staircase is 2.8. So again, it's just coming up with the triangle that I think is the most difficult part. So it says the distance between two floors of a home. So like this is your second floor and this is your first floor. Okay, so the first thing you're going to do is draw two floors. First floor, no, we're not done yet, Alex. First floor, second floor. I mean, I don't know, you tell me, is that a triangle? Okay, it says the horizontal length, the distance between the two floors. So the distance from here to here is, 2.5 meters. So I'm going to go like this. Does that make sense? Are we okay with that so far as to why I've created this line here? So the length or the distance from floor 1 up to floor 2 is 2.5 meters. Then it says the horizontal length of the staircase is 2.8. So I know we still have to draw our staircase in, but it's saying the horizontal length. So you know that that looks like this. That does not look like this, right? This is like a diagonal. This would be our hypotenuse. So the horizontal length of the staircase is 2.8 meters. So I'm going to put 2.8. I'm just going to make this a little smaller. So then we have this, and now I could draw in that. So first floor, second floor, distance between the two floors, horizontal length of the stairs, and now our actual stairs. So like, and so on and so forth. Now, the first question says, and now what angle is this here? What do we know that that is? Good, thank you. Now the first question says determine the slope of the staircase. So this is actually very straightforward. We don't have to overthink it. What do we know slope also represents? When you were graphing, in order to get the slope, what formula would you use? So that's the equation of a line. So our equation of the line would be in y equals mx plus b form. But in order to get the slope, what would we do? Angelica? So yes, that is the most specific version, but that is also what over what? What would we say to get the slope? Blank over blank. Rise over run. Okay? So this is our staircase here. This is really like our line. We have our rise, and we have our run. Okay, so this one is very straightforward. You're just going to say slope equals rise over run. And then you're going to plug in your rise, which is 2.5, and your run, which is 2.8. And you're going to get 0.8929. We okay with that? Now, remember, you need to label a diagram for word problems, and you need to include let statements. So before we actually solve B, we need to come up with a let statement. So B says determine the angle of inclination of the stairs. So it wants to know the angle that the stairs are inclined at. Okay, so again, this just ultimately comes out to practice and being able to pick out that angle. But we want to know the angle in which the stairs have an incline. So that is going to be right here. This is going to tell you the angle of inclination. This is the angle in which the stairs are going up, right? Okay, is the angle in which the stairs are going down, but this is the angle of incline. Are we okay with that? So we want to figure out this angle based off of this question. Okay? So we're going to do a let statement. It wants the angle of inclination, and our angle of inclination is represented by theta, so I'm just going to say let theta be the angle of inclination of the stairs. That's all it's asking. So I really just turned that into a let statement. Now, here comes the easy part. We want this, we have this, and this. So you guys tell me, what are we going to use here? So TOA. We want this angle. This is what side to theta? And this is what side? Good. So what are we going to use? TOA. Good. So tan theta. If you had labeled this like ABC, it would have been fine if you put tan B. Okay, it doesn't matter. Equals up over adjacent. Tan theta equals opposite is 2.5. Adjacent is 2.8. When we want to get the angle, theta, what operation do we always have to do? The inverse. So theta equals tan to the negative 1, 2.5 over 2.8. And remember, you could have put this into a decimal if you wanted to. And if you were to punch that into your calculator, you would get 41.8 degrees. So we can put that here. Now, and what is our last step when we have word problems? Therefore statement. So therefore, the angle of inclination of the stairs is 41.8 degrees. Questions with that guy? Okay, good job, guys, so far. Okay, so you're going to have questions that ask you for the angle of elevation and the angle of depression. So before we actually go and do those types of questions, you guys need to have an understanding of what that means. So it says here, if you are standing on a cliff beside a river, so here's this person standing on a cliff beside a river, and you look down at a boat, the angle that your line of sight makes with the horizontal is called the angle of depression. So we always have a horizontal in these types of questions, and this is the person, so like looking straight would be the horizontal. Okay? Looking down at the boat, because they're looking downwards, we call that the angle of depression. So there's always going to be a horizontal, and in this case, if we're looking down towards here, we call it angle of depression. Is that okay? Does that make sense? If we're looking up to something, so then it says if you look up at a helicopter, the angle that your line makes with the horizontal, because we're always going to have a horizontal, is called the angle of elevation. So pretty much, like if you have a word problem where it's looking upwards, that's going to be the angle of elevation. And if you have a word problem where it's something downwards, that's going to be called the angle of depression. Okay, but very important is also remembering about the horizontal. Okay, so that's kind of like the straight line, and then we have an angle either looking up or looking down. Did I have you guys? So, just to kind of get like a better visual of that. So, if we have a person looking up to a helicopter, that is going to make an angle of elevation, which is a triangle. if we have a person looking down to the boat, that is going to be an angle of depression. Is that okay? Okay. So using that information, let's do the next question. So again, I swear it's just coming up with our diagram of our triangle that I think is the most difficult part, and then we're like smooth sailing. So a search and rescue airplane is flying at an altitude of 1,200 meters towards a disabled ship. You guys ever been on a plane and you bring up the map and it says the altitude at which the plane is at? So really that's like the height off the ground. Okay? The pilot notes that the angle of depression to the ship is 12 degrees. How much further does the airplane have to fly to end up directly above the ship? So you have to start somewhere. So let's just put P as a point of our triangle for our pilot in the helicopter. So I'm just going to start by putting P right here. That's going to kind of be like the start of our triangle. So it says the pilot is flying towards a disabled ship. So it's not directly above it right now. We know that it needs to get there still. In the end, we want to know how far it needs to go in order to be directly above the disabled ship. So I'm just going to put my S somewhere away from P because we know that it needs to get to the ship. Okay? So I'm just going to put my S right here. So think about the pilot's here, and the ship is over here. Like, actually imagine it. Like, this is happening in real life. There's a pilot in a helicopter, and there's a ship a little ways down, and he wants to get directly above the ship. Okay? And we know that from the pilot down to the ship is how many meters? What'd they give us in the question? What's the elevation from the ship up to the pilot? Okay? So I'm just going to say this to this and that. This is going to be where our airplane wants to be. So I just happen to label that A. If you didn't label that A, that's not wrong. Now it says, a search and rescue airplane is flying at an altitude of 1,200 meters. So pretty much from here up to the pilot is 1,200. So can you guys tell me what side we are going to label 1,200? So remember, the pilot's not exactly above the ship, but it's still from here to here is still 1,200. A to S. Good job, Alex. So A to S, we are going to label 1,200 meters. Then it gives us the pilot notes that the angle of depression to the ship is 12 degrees. So can someone point out to me, so the angle from the pilot to the ship is 12. So can someone tell me what the horizontal is here? What line is really representing our horizontal? So remember, like, when we saw the cliff, it was the person standing on the cliff, and for them it was just like straight, looking straight was the horizontal. So if we have a pilot, and he's just looking straight, what must be our horizontal? P to A. So if then it says the pilot is looking at the ship at an angle of depression, which means up or down, down of 12 degrees, which angle am I going to label 12 degrees? Just tell me the angle. P. Right? So just right here is our 12 degrees. Does that make sense? So I know that it takes a little bit of time to come up with your triangle, but once you come up with it, then it's a little bit more straightforward. So I'm going to label this my right angle, because we can see that that's the right angle. And now we just need to figure out what the question is actually asking for. It says, how much further does the airplane have to fly to end up directly above the ship? So, which side are we trying to figure out? It wants to know how much further the pilot needs to go to get directly above the ship. So are we trying to figure out this line here, or are we trying to figure out this line here? And we want to know how much further the pilot needs to fly in order to get to be above the ship. P to A. Does that make sense? So it's just picking out the right information. So I'm just going to label that X because that's what we want to know. This side we know is hypotenuse because it's opposite the right angle. So now that we've done this, before we actually go and do our question, we need to do our let statement. So we know that this is what we actually want to figure out now. I've labeled it X. So I'm going to say let X be the distance. If you said length, that is fine too. I would not take marks off of that. To the ship, and I'll say directly above it. Okay, I want to figure out this. Well, what do I have? I know I have this angle. So opposite of the angle is opposite. And then I want to figure out, is it the hypotenuse or is it, what's the other one called? It's hard to ask the question without giving the answer. Adjacent, right? So we have angle P, we have O, and we need A. So if we did SOHCAHTOA, can you guys tell me which one we're going to use? We have this, which you guys told me that was opposite, and we need X, which is adjacent. So we have O and we need A, so that's going to be tan. Okay, so tan theta equals opposite over adjacent. Well, we have theta, which is, what's our theta for this question? We have an angle, 12 degrees, so tan 12 equals opposite is 1200, and we'll put X down for adjacent. In order to get rid of this fraction, I need to multiply this side by, and this side by. This crosses out. So now I really have X times tan 12 equals 1200, but I want X on its own. So what do I need to divide by to get X by itself? Tan 12. You know what, let's do this in a new step so that it's not so much going on in one line. So now we have X tan 12 equals 1200. We're going to divide by tan 12. What you do to one side, you have to do to the other side. Okay, and remember, if you like it better, you could have put tan 12 into a decimal. So on your page, it could look like 1200 divided by an actual decimal at this point. It's up to you. If you do 1200 divided by tan 12 in your calculator, you are going to get 5,645.6. What's my unit? Meters. Okay, and I'm going to have to do my therefore statement over here. So I said, therefore, the plane has to fly 5,645.6 meters to be directly above the ship. Yeah, more than likely, because technology is super good. But in order for radar to be a thing, what do you think they use to program this stuff? Right? Math. So as much as technology saves us from actually having to do the mental calculation, that technology was developed using mathematics. And coding and all that stuff. Good? What do we have? 3 more. Did everyone get that? Alright, here we go. I think this one's pretty easy. A construction engineer determines that a straight road must rise vertically 45 meters over a 250 meter distance measured along the surface of the road, which was representing the hypotenuse. Calculate the angle of elevation. So, it says, straight road must rise vertically 45 meters. So vertical looks like this, right? So if we have this, this, and this, yeah, I think I did draw that. So I'm going to do that. Which side am I going to label 45? If it says it's vertical 45 meters. The right side. Okay, so that's the first step. You should be able to pick out that this is 45 meters. Then it says over a 250 meter distance, so now we're like, okay, is that going to be this or is that going to be this? But then it says this represents the hypotenuse. So then where must I put 250? Along the hypotenuse. Now it asks to calculate the angle of elevation of the road. So if this is the road that's like on an incline, can you help me label my angle? Which angle is it going to be? Did I label this? No, I didn't. What makes sense? Is it going to be this angle? Is it going to be this angle? Well, it's not going to be this because we know that's our right angle. So we have two options, and we want to measure elevation looking up, not looking down. So which is it going to be? This one or this one? This one. Okay? So this is going to be our theta. I labeled that. Now, in these types of questions, if this is my angle of elevation here, what do I call this line? Remember what we always have what is this one called? When we have this stuff, we have an angle of elevation, and then the straight line is always called what? Okay, good. I don't want you guys to forget that word because sometimes you'll see that word, and I want you to remember that that would be this line. Okay, so I am going to put that here. Like that line there is the horizontal. Okay, so before we even go and do our calculation, we need to do our let statement. So it asks to calculate the angle of elevation. Well, we know that theta is going to be our angle of elevation. So I put here, let theta be the angle of elevation of the road. So, if we want this, well, we have, what's this side called? If we want theta, then this side is opposite. And we also have hype. So SOHCAHTOA, what are we going to use? What trig ratio? Sorry? We have O. And we have hype. So sine. Okay, we're going to use sine. So sine theta is what we want, equals op over hype. Sine theta, op is 45, hype is 250. In order to get the angle, what operation do we always have to do? Inverse. So remember how to write it properly. You have to do sine to the -1. 45 over 250. Again, you could have put this into a decimal. I think it's 0.18 something. And then theta equals, you would get 10.4 degrees if you punch that into your calculator. Therefore, the angle of elevation of the road is 10.4 degrees. Questions about that one? Okie dokie. Jackie works for an oil company. She needs to drill a well to an oil deposit. So here's Jackie. The deposit lies 2,300 meters below the bottom of the lake. The lake is 150 meters deep, so this question just has one extra step in it. So it's saying Jackie is here. She needs to drill a well to an oil deposit, which is down here. The lake itself is 150 meters deep, so from here to here is 150, but then below the well is 2,300 meters to the deposit. So this here is already 150, and then from here to the deposit is another 2,300 meters. Is that okay? Does that make sense? Okay. The well must be drilled at an angle from a site on land. The site is 1,000 meters away from a point directly above the deposit. So we need to label this guy. So right away, I'm just going to draw my triangle because we know Jackie's over here, the well is over here, the deposit's over here. So I'm just going to go like this. Okay, the diagram was set up like that for a reason. So we know from, let's just say this is the top of our, I could have drawn it up here, sorry, but let's say from here to here is the pond. So remind me, what length is that? Or distance? Of just the pond? And then from the bottom of the pond to the oil well, 2,300. So I was just going to say, what do you think you should do in order to get the full length of this side? Add them together. If you were to add these guys together, 2,450. So really, we've just taken care of the extra step. Now let's label the rest of our triangle. It says that the well must be drilled at an angle from a site on land. The site is 100 meters away from a point directly above the deposit. So the point on land above the deposit must be here. Does that make sense? So we want to figure out, sorry, I need you to add this. I forgot to do this at the beginning of the question. It doesn't actually tell you in the question what to calculate, so I'm giving it to you now. Calculate the angle of depression to the deposit. Okay, so they tell us that from here to here is the 1,000 meters. And we want to calculate the angle of depression. Well, this line here must be representing, what is it called again? If we're dealing with angle of depression and angle of elevation. What is the straight one always? The horizontal. And if we want to figure out the angle of depression, so looking down, what angle must we be trying to figure out? It's not this one, so it must be this one or this one. But this one, which one represents looking down? The top one. Okay? So this is our theta. So before we do our calculation, let's do our let statement. It says calculate the angle of depression. Well, we know that theta is going to represent our angle of depression. So I'm going to say let theta be the angle of depression, what did I say, to the deposit. Okay, so if we want this, we have this, which is which side? Good, so I'm just going to put that right here. And then this is height, so this must be. If this is height, then this one over here we also have adjacent. So, SOHCAHTOA, what are we going to use? So we want theta, we have O, and we have A. So it's going to be Tan. Good. So, tan theta is op over adjacent. Tan, what's theta? We don't know it. That's what we're trying to figure out. Op is, make sure you put the total, 2450, over take the inverse to get the angle. If you punch that into your calculator, you will get 67.8 degrees. And again, you could have put this into a decimal if you like that better. I put it here, I think it's 2.45. Therefore, the angle of depression is 67.8 degrees. Last one. Multi-step. This next guy. Last one. Yep. Yep. It's just like any other problem. You need to go step by step by step, right? So like this is always what we start with. So I should always see the most basic like formula or equation that you would use for the question. And then we still need to sub in what our op and adjacent are. We're not quite there on solving theta yet. We still have to sub in what we have, right? It's always like sub in what the question gives you, and then eventually isolate for what it is that you want to find. Okay? All right, here we go. Last question. She a big one. Nadia, whose eyes are 1.65 meters off the ground, is standing on a cliff 130 meters above the water. Okay, so we have, I'm going to do this on two pages. So I'm just going to draw the diagram here, and then I'll do the calculation with you on the next one. So we have Nadia, whose eyes are 1.65 meters off the ground and is standing on a cliff 130 meters above the water. So let's just say that in general, if this is Nadia, then this must be the cliff right here. So the height of Nadia is 1.65 meters. Let's just put that in there. So from cliff to her eyes is 1.65. That's what we have so far. Then it says she's standing on a cliff, and the cliff is 130 meters above the water. Nadia looks down at an angle of 57 degrees from the horizontal to see Colton about to be eaten by sharks. So if she's looking, so this is the cliff. The cliff is now 130 meters to the water, and she's looking down from the horizontal to Colton, who's over here somewhere about to be eaten by sharks. So right away, guys, I'm going to draw in the horizontal, because it does say that she looks down at an angle of 57 degrees from the horizontal to see Colton. So I'm going to say from your lines better be nicer than mine. So horizontal, she is looking down at Colton, which is C. What's the angle that she's looking down at? 57 degrees. Now I'm just going to close my triangle up. So now, if this is Nadia, who is 1.65 meters tall pretty well, but then from here, the cliff, to where Colton is in the water, is another how many meters? So I'm going to say from here to here. How many? 130. Good. So if from here to here, where Colton is, so this right here, is this plus this. Does that make sense? So from the top of Nadia to Colton, this is the height. So where can I put this plus this on the triangle? Where does that really represent? Yep. This is our right angle. N, Nadia. We're not even going to label this yet. Okay, sorry. Label this N for Nadia. No, because this is our horizontal. So if this is our horizontal, and then Colton is directly below it, this would be our right angle. Nadia is looking down to Colton. So if this is the horizontal and she's looking down, this is our angle of depression of 57 degrees. Oh, I was. Sorry, I wasn't. So I'm misunderstanding your question. I'm asking you if this from here to here is 1.65, and then from the top of the cliff to Colton, or the water, really, is 130, then we're going to put this together. We're going to add it, which is going to be 131.65 meters. Thank you. But where am I really going to put that on the triangle? Which length? Which side? The horizontal, we only have two options. The horizontal, and then from here to here. The vertical. Okay, I apologize, Alex. I wasn't understanding what you were saying. But you are right. If this is what you were saying, you are right. Sorry, what was that question? Because realistically, like, I don't want to keep like adding so much to the photo, but from here to here is like the cliff. And then from here is the top of the cliff to pretty much the height of Nadia. And then down here is like the water, where Colton is. Does that make sense? Okay. So now, we're not done yet. We've only gone halfway through the question. So we have Nadia, we have Colton, we have the angle of depression in which she's looking down at him. Then it says Nadia then looks up at an angle of 46 degrees from the horizontal. So this is our horizontal, and now she's looking up to see Robert flying a rescue helicopter. So we have an angle of depression, and now we have Nadia looking up to Robert. Okay, we're almost there. Let's just get through this. It just takes a lot of time to draw the triangle here. It's step by step by step. Robert is directly above Colton, and due to weather conditions, he cannot lower the helicopter any further. So Robert is here in a helicopter, and Robert is directly above Colton. So this makes sense. Robert's up here. This is our angle of elevation, which is 46. Guys, it does make sense. As much as you don't want it to, because you don't love the question, it makes sense. This could be a real life situation. This is actually like the real world application of math. So this actually, there's rescue missions all the time. Is there not? So let's get through the question. Robert wants to save Colton by sending down a 220 meter long rescue ladder he has on board. We need to figure out if the ladder from where Robert is long enough to reach Colton. So, draw a well-labeled diagram. Well, we've been doing that as we've been reading the question. So, this, so I want to say like just from here to here is 131.65, so please don't forget that. So pretty much, you guys tell me, what are we trying to figure out here? Because Robert's up here. He wants to drop a 220 meter ladder down to Colton. We know from here to here. So what do we need to figure out in order to determine if the ladder is long enough? From here to here. Does that make sense? Okay, so I'm going to put X there. Now, in order to be able to figure out x, so if we say, okay, we have this angle of elevation of 46 degrees, but can we figure out x? Like, do we have any other unknowns? We only have one unknown of the top triangle. So, can we figure out x right now with only 46 degrees? How would we do it, Mysam? Like, if we only have 46 here, and we want to figure out x, what other number would we have to punch into an equation? Do we have one? Or do we maybe need to figure out something down here where we have 1, 2? Okay, so if we have this here, and we have this, which is opposite, what else do you think we could figure out that would help us then to come up here and solve for x? You guys see what I'm saying? The adjacent of this angle, right? So if we have this angle here and we have opposite, well, if we figure out adjacent, which would be this line here, then we would have this angle 46. We would need to figure out opposite, but then we would have adjacent. Does everyone see that? Okay, so let's do that step first. So before we do that, we will make our let statements. So let x be the distance. Again, if you said length or height, I would never take marks off of that. From horizontal to helicopter. I'm sorry, that wasn't very nice writing there. Let x be the distance from the horizontal to the helicopter. Does that make sense? X is from the horizontal up to the helicopter. We want to figure this out though, so I'm just going to, for our let statements, label this y. Let y be the length of the horizontal. Okay, so y is really the horizontal. We said that this was the horizontal from the beginning. We're going to solve for y first, then we're going to have this guy, and then we can solve for x. Okay, so before I go back, if we have this angle here, and we have this side over here, what do we call this side? What do we call this side from this angle? And we want to figure out this one, so this is what? Good. So Katoa, you guys just told me that we have opposite and we want to figure out adjacent, so which one are we going to use? Toa. Good. So tan theta equals op over adjacent. What is my theta for this question? What's the angle that we have? 57. Op is? Good. And adjacent, we don't know, so I'm going to put in our y there, because that's what we labeled it on our diagram. So in order to get rid of this fraction, you guys know we're going to multiply both sides by y. Cross it out. Becomes y tan 57 equals 131.65. In order to get y on its own, what am I going to do? Wonderful. What you do to one side, you have to do to the other side. Y equals, you would do 131.65 divided by tan 57, and you would get 85.5 meters. And again, if you wanted to put tan 57 into a decimal, you could have done that. Okay, so let's go back, and I'm just going to highlight. We just used this. Oh. We just used this, and y to get our first calculation. So now, I know I only have so much space, but I'm going to put here for adjacent. 85.5. Now, let's use green. We want x. So we have this. Yes, Alex? Sorry, say that again. Yeah. You're so right, but we don't even have to do that because now we have this angle and this side. So now we can figure out x. But you're right. That's something else that you could do. Okay? Anyways, I wanted this to be green, and then it went yellow, and I'm very upset. So I'm just trying to show you that this was one calculation, all the yellows, and then this is another calculation, all the greens. So we have this angle. We want to get which side? What's this guy here? Opposite. Good job. And we have the adjacent, which we already labeled. So opposite and adjacent. So again, SOHCAHTOA. Which one are we going to use? Tan again. So tan. So we'll say this was number 1. This is number 2. What's theta? Good. Opposite. Do we have it? What did we label the opposite? Good. What's adjacent? Okay, so see how we needed to get that value in order to do this? In order to get rid of my fraction, I'm going to multiply this side by 85.5. This side by 85.5. Crosses out. Someone do 85.5 times tan 46, and you would get 88.5 meters equals x. So we had to do all of that diagram drawing, plus that first step, in order to eventually get this, which we're not done yet because the question wants to know, will the ladder be long enough? So we can come back over here, and now this here is 88.5 meters. Now remember, he only has 220, so he's up here, Colton's down here. So what are we going to do next? We have this and this now. Sorry? Exactly, and then we're going to see if that is greater or less than 220. So 88.5 meters plus 131.65 gives us 220.15 meters. Therefore, the ladder can't save him. I'm sure in real life, yes, that would actually happen. I think that he would be saved, but based on the math, the ladder can't save him because it's not long enough. Oh, sorry, only 0.15 meters short. See ya.
If this is a real life application and Robert's already on his way with the ladder, what would be the point of calculating this? If he's already on the... When you do this before you grab the ladder to see if you
yes. Robert would not be in the helicopter doing this calculation to see if the ladder was 220. But this type of calculation would have been done
by Robert before he grabbed the... Or would it be...
Yes, and the calculation would have been done so that he could be saved. They wouldn't bring a 220 meter ladder if he needed 221 meters. But this... You know what?
Is it perspective? It'd be Robert doing the math, right? If it started off by saying Nadia, blah, 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 because Nadia was doing all this.
Nadia was only there to help us to create our triangles. That's why Nadia was there.
She was doing that? What was she going
In
Yell at Robert.
in like real life, there would be like experts who would be doing this calculation before the rescue mission was already a thing.
How long do you think it would take for them to blow?
Yeah, and then they use the video.
I don't think it would take very long.
Like how long?
It took us 15
Again, like they would know right away based off of like technology and radar the distance from the helicopter to Robert already. So it would literally just be like, let's get a rope that's that long, right? Yes, go ahead. Okay, so this was a question, guys. This question here was a question that you had to draw two triangles for, and you had to use information from the first triangle to be able to in order to answer the actual question of the problem. Okay? So that one is a little bit more difficult. Okay, so you have this now. You have word problem practice that you can do. Okay, and then this afternoon we have 4 slides. 4 slides to get through, okay? Questions? How do we feel in general about word problem stuff? Like, were they not too bad, right? Just create our triangle and then use our SOHCAHTOA trig ratio. Okay? So this one was a little bit more difficult and a lot of reading. But once you get it, once you get the triangle, these calculations were very straightforward. Okay? Okie dokie. Hi, Miss. How are you?
Good, how are you?
Good, thank you. Okie dokie, so you have lots of word problem practice that you can... 5 minutes. No, they just made the announcement yesterday about how there's 9s and 10s in the hallways at the same time, so you got 5 minutes. Okay, miss, so we just did trig ratio word problems. So just like using SOHCAHTOA. Like we haven't done sine or cosine law yet, just like the more straightforward ones. Thank you. And they have it, the homework already. Okay.